Ladies and gentlemen, hello and welcome back once again to another episode of Future Proof. Your host here, Eric Kavanaugh, and we're going to talk to one of the smartest guys I know in the world of open source and enterprise technology. Quite frankly, Justin Reock is going to join us. So this is actually a briefing room webinar with Open Logic by Perforce, best practices for building an open source stack. This is cool stuff, folks. So there's Justin, there's yours truly. I'm going to talk for about 10 minutes, but bring Justin in to comment on some things as we try to figure out what's going on in this really remarkable and dynamic time in our industry. So what's going on? Technical debt. Justin lives down in Florida, so there are lots of anchors around Florida, some of them from the 1800s and 1700s, some old stuff out there. And I thought this is a perfect metaphor to discover and discuss technical debt. So what is technical debt? Basically, it's probably 80% of your IT infrastructure right now, I would say, is technical debt. It's all the technologies that are running your business that have been around for 5, 10, sometimes 25, 30 years. A lot of businesses are still running on mainframes. There's a lot of Unix out there still in the world at large. There's a lot of technical debt, and there are tons of different ways that you can solve for this. So what's happening right now with COVID, I view COVID as the ultimate forcing function because it forced us all to change our ways. And I often quote Carl Hightower, the chief data officer for Novant Health, who said on our radio show a while back last year that they tackled 5 years of digital transformation in 5 months. It goes to show you what you can accomplish when you set your mind to it and you get rocking and rolling. And when you must do it, you have to get that done, you're going to get it done. So what does the future hold? Well, cloud native to me is the future, right? So cloud native is a principle. It's a design architecture, if you will. It's a way of thinking about how you leverage the cloud. I've heard some really fun comments from folks. Maybe Justin, I'll bring in to comment on this, but one company we're working with said cloud native is basically AWS native. So whatever they do, that's what these folks are working on. But Microsoft and Google are very serious players right now. But what are your thoughts real quick, Justin, on cloud native as the vision that we're all striving towards to help us solve for technical debt?
Great question. And I think we have to talk about whether we're talking about building cloud native apps on our own, or if we're talking about consuming cloud native services, right? So those are two kind of different things, right? The idea of a cloud native app in my mind is one that I think the easiest way to define it is an app that adheres to as much as possible the 12 factors of application development. And so that's a really good standard. If you're not familiar with it, check it out at 12factor.net. It's a standard that was put together by industry thought leaders who you've definitely heard of, you know, folks like Martin Fowler, folks like Robert Martin, folks like Gene Kim. And it's basically a set of standards for reducing friction inside of a DevOps or cloud native organization's application space in the cloud. Now, I kind of like to say, if you could almost envision a continuum, and you know, I should have thought of it, but I have a little visual handy, but maybe you can just kind of put this continuum in your mind. 12 factor doesn't mean like you have to check off all 12 factors of this application in order to have a successful cloud migration, right? What it does mean is that the more of those factors you can adhere to, and these are things like not dropping log files on your own host, but shipping those log files out as event streams so that they can fit natively into things, or running your application as a single process so that it can be managed by some external wrapper like Docker or Kubernetes or whatnot. So, you know, I think, are you on mute? Whoops. And so I think for cloud nativity, when we're talking about if we're building our own cloud native apps, we want to conform as much as possible to the 12 factors. And what we need to think of in terms of that continuum is the more my code adheres to 12 factor, the less friction I'll experience when I drop my application off into a multi-cloud environment, right? So it's really a good standard for saying, you know, will I easily be able to take my app, put it in a cloud, multi-cloud, possibly even a container-based environment like something like Kubernetes? Can I do that with minimal friction and with good success? The 12 factors are a roadmap to get you there. So that's a cloud native app. A cloud native service is what was described with the Amazon comment. And I would agree that in practice, that is what most people are kind of defining as cloud native right now, just because of from a sheer adoption standpoint. Amazon, they got to public cloud model that was really successful first. They evolved the hosting model first. They've had a ton of time to be able to build individual services now into their cloud, which reduce friction in using specific technologies in their cloud. So things like RDS, for instance, that's where if you want to use Postgres or MySQL natively inside of Amazon's EC2 instance, instead of having to say, create and spin up a vanilla instance of an image and then install a database onto it, you can just click a few buttons inside of the interface in Amazon and say, I want a Postgres database spun up here. That's a cloud native service, right? That's what's saying that, Amazon is now offering for a subscription fee, the ability to more easily use certain technologies that are already prepped for 12 factor and that are already performing well in the cloud. So I think it's a really good question. And it's a really important distinction that a lot of people, I think, miss.
Okay, good. Let's talk about the value of open source. And as you look around, and you and I are in the industry here, so it's kind of hard for us to appreciate the speed at which the needle is moving, I guess, as a way to put this. But if you put your mind back 10 years ago or even 20 years ago, it's a vastly different world. And I think the cloud expedited this. But let's think about, just for example, the most cutting edge scale out technologies available today tend to be open source projects, whether it's Kubernetes, we'll talk about that, whether it's Cassandra, whether it's Hadoop, of course, even though that's kind of getting folded into things now. You think about Apache Arrow, for example. There are so many of these open source projects that have spun out of large organizations like Kafka from LinkedIn, for example. Cassandra, of course, is now used by many, many companies as a production database. These are open source projects, and they will often have a business model on top of that. But so you think about the cost, obviously, is good, especially if you have really good people. Then all you have to worry about is the solutions you build and the infrastructure, the people, basically. You think about Kubernetes, I'm pretty sure it's the de facto operating system for hybrid cloud. When you think about performance, something like serverless, for example, some of these architectures that people are using are tremendously fast and very inexpensive too. So like all of these factors come together in my mind to say that open source is the de facto innovation engine, if you will, for enterprise computing that is much different than it was 20 years ago. I think it's really accelerated to an incredible pace with Kafka, with Kubernetes, with some of these other more recent ones. But what do you think about the trajectory of where we're going and how we got here?
Well, yeah, I have a few comments about that one. So first of all, I think that in some of these cases, the choice to use something open source is just in and of itself a DevOps action that helps to eliminate friction from an organization, right? So, when we talk about all of these products that are coming out that are spinning out of organizations that have solved problems, like you brought up Kafka, you've got related technologies like Spark that are solving big challenging problems like data reduction and mapping and optimization of data pipelines and things like that. The fact that CI/CD pipelines, and not just CI/CD pipelines, but also infrastructure as code mechanisms and automated deployment mechanisms and elastically scaling mechanisms, all these things rely on disposability in the environment, another of the 12 factors, right? They rely on the ability to spin up, spin down the environment very, very quickly, right? So this is where the performance stuff comes from. But also, if you think about it from a licensing standpoint, and if you think about it from a standpoint of the accessibility of the code and the ability to pull patches, updates, new releases, initial releases from public repositories that don't have a lot of friction out in front of them, like a paywall or something where you have to log in or present a license or something to get the software. If you think about that mechanically, it's just easier to pull free software into an automated substrate like this and then expand it in any direction that you want, because you don't have to run into procurement friction, license friction, anything like that. So while I think it is definitely like the future and eating the world in terms of what everybody wants to do with accelerated DevOps and container orchestration and all that, I also just see it as a fundamental action, like a safe and supported open first policy as a fundamental action that brings a business closer to DevOps maturity.
That's very interesting. Let's put up this next slide. As I was preparing for this event, I was thinking to myself about the industry and where we've come from, where we've gone. Obviously, IBM has a very long history of supporting open source. IBM was responsible for hardening Linux 20 odd years ago with a roughly $1 billion investment, according to my research. And one of the clever people we had on the show in the past said, when he heard that number, he goes, yes, and do you know how long it took them to make that back? I said, no, how long? He said about 12 months.
Right.
So it's just fascinating that IBM stepped in here and took what was, let's face it, it was viewed as a hobby back in the day, the Linux operating system, took it, hardened it to enterprise class. It was way back in 2005 when I got a press release. I was working for the Data Warehousing Institute. I got a press release of some new Oracle database that was coming out and how the first OS for which they designed it for was Linux. And I asked one of our analysts, I'm like, why would they do that? And he explained to me the story. And I was like, holy Christmas, that's pretty impressive. And now let's face it, I mean, Linux, you have a whole separate talk you could do on this, but there are different versions, obviously, of Linux out there, and they all have their pluses and minuses. And folks, we'll talk about this when Justin shares his screen. He's got this open source stack builder he's going to walk through. But if you think about what happened, that's the foundation of the information architecture is your operating system. And when it changes all the time, that's a problem. That's a problem for people downstream, who is basically everybody in IT and in the business is downstream of that. So this was a big deal. And now if I look at IBM buying Red Hat for a tasty $34 billion, you said before the show that has more to do with them buying OpenShift, which is related, but not exactly the same. But to me, this is as good a commitment and value proposition for open source as you're going to get, that one of the 5 big companies in enterprise IT, IBM, Big Blue, one of the longest standing ones, is going 100% in on open source with $34 billion, because Red Hat is an open source consultancy. Basically, they're the folks who have been the go-to partner for big companies rolling out Linux as their operating system. They do a lot of other things too, obviously, but this is a pretty big story. And to me, it's kind of a slam dunk for the future of open source. But what do you think, Justin?
Yeah, I think it provides a lot of validation to, the fact that a big company like IBM is ready to invest this heavily again in open source. We partner with IBM. We have a very strong partnership with IBM around our OpenLogic support and services, and IBM actually not just resells that offering, but we actually back up their tier 1 and tier 2 open source support offerings. And so the tier 3 and tier 4 levels of that support are actually fulfilled by the OpenLogic organization. So, the IBM has been making really good investments in open source for a long time. I think despite the denial of a lot of people who are maybe more purists in the industry, everyone I think would love to believe the sort of idyllic story that open source sort of survived on its own and that it was this big revolutionary phenomenon. I'm not trivializing it. It is. Open source and free software as a phenomenon is larger than any one organization will ever be as a software phenomena. And it's been incredibly successful. But plenty of large enterprises have helped along the way, right? And it's just it's not truthful to claim otherwise, right? IBM's $1 billion investment in Linux back in late 90s, very early 2000s, I think, was a signal, I think, to the marketplace that said at that point, we want Linux to be ready for prime time and ready for enterprise, right? And I think that it was, to IBM's credit, a very long play for them in terms of remaining relevant against competitors at the time for a longer term strategy. If you look at, say, Microsoft's interesting relationship with Linux, right? That's one that I like to pull out alongside, where nobody was bashing Linux like Microsoft was bashing Linux in the 90s, right? I mean, they made a system,
I remember, yeah.
Right? Linux is a cancer, right? Who can forget that? So now what's happened, there's more Linux running in Microsoft Azure than there is Windows Server.
Wow.
Windows itself, now a lot of folks are familiar with the Linux subsystem for Windows that now ships in Windows 10. If you want to run Docker or Kubernetes inside of Windows, you can do that. If you want to run Minikube inside of on a Windows box, you can do that because you can install a stripped down Linux subsystem powered by a number of different flavors right into Windows. Prognosticators have even talked about, looking at this direction and saying, gosh, Microsoft or Windows as we know it may just change to become a GUI layer sitting on top of a Linux kernel, right?
Wow.
So I look at this and I'm like, okay, well, IBM made this big investment back then. Since then, it became Red Hat's biggest retailer, right? It was their biggest reseller, I should say. They've had a very close partnership with Red Hat since then. I think what IBM wanted to do was have a real play for DevOps and cloud and container orchestration. I think they were having trouble kind of making that stick and work on their own. So they bought their biggest partner, mostly I think for share in their newest technology, that's OpenShift. And I think we can also look at their market behavior now in how much they're just pouring into OpenShift as an indicator that really was kind of their primary motive. But in terms of what it does for validating the open source landscape, I mean, it put dollars behind it,
Yeah. Well, let's talk about OpenShift for a second. I had this fun slide that just shows the surfer, and I'm saying don't get overwhelmed. And the way to avoid that is something called a program office. We'll talk about that for a couple of seconds. But if you would, for our audience, we have a whole range of folks on the call today. Tell us about OpenShift top to bottom, and why is this such a big deal? What does it compete against? Why do you think IBM would be so keen to get a piece of OpenShift? I actually heard it was a bit complex in the early days. I think maybe they sorted some of that out.
Still complex. So let's be clear about Kubernetes, which OpenShift is based on, and which a lot of these other container orchestration frameworks are based upon. Kubernetes is a data center in a box, 100%. You have an entire networking fabric, a storage fabric. You have actual boxes in the form of containers, right? You have it plugged into generally plugged into a CI/CD type of pipeline so that you can release into a modern, non-constrained environment. All right. So what's the purpose of all this? Well, what's the purpose of DevOps, right? I mean, you have to start there. And there is a very distinct definition and purpose when you go back historically, right? Let's trace things back a little bit to like 2013 and the DevOps Handbook publication by Gene Kim and some of those related authors, where DevOps really became something that I think businesses were striving to achieve. And I think a lot of people who understand business and who had MBAs and who were used to older business strategy understood exactly what was happening with DevOps. Whereas I think folks who maybe weren't juxtaposing the real goal of DevOps, which, let's be clear, the goal of DevOps is to make a software business more money. Right, that's what it's supposed to do. Those who were aware of that purpose saw its early beginnings easily, because you can trace DevOps and those patterns back to lean manufacturing and agile, and you can trace those patterns back to Eli Goldratt and the goal and the theory of constraints in the mid 80s, which is now, of course, required reading in much MBA classes. Well, it's interesting. I see that comment that. Not a chance MBAs have even a dim clue what DevOps is. But if they connected the dots, they would almost certainly understand it immediately, because if you go back to a lot of Goldratt theory of constraints, and all this stuff, what those philosophies basically said were that we have to consider an organization as a complex machine. And a complex machine has three basic parts to it: inventory, throughput, and cost, right? And you want a machine to create throughput, and you want it to create throughput from its inventory, and you want to do that while keeping cost low. All right. So that is effectively the notion of the theory of constraints, right? The theory of constraints says we need to eliminate bottlenecks in an organization in order to move our inventory out to create throughput faster. Right. What does that mean? It means that if I'm, say, a parts manufacturing organization, which is where the theory of constraints came from in business, I have a parts manufacturing factory, something like that. By eliminating bottlenecks in that factory, I can take the inventory, the raw materials that my factory needs to produce, and I can produce more code or excuse me, I can produce more material faster. I can get that raw material out in the market, making money for me faster. I can increase my throughput. All right. That's that very, very layman's overview of theory of constraints. I highly recommend reading The Goal if you haven't read it. And it is still required reading in a lot of MBA courses. Now, if you fast forward to another book called The Phoenix Project, the Phoenix Project was written by Gene Kim, who was in many ways one of the early, coiners of the term DevOps. He was the chief author of the DevOps Playbook. These are all books, by the way, that I keep on my shelf pretty much all the time, so I can even show you what they are. Here is The Goal, right? This is the third edition of it, which is available. This is Gene Kim's DevOps Handbook, okay? And this is the Phoenix Project. Now, the Phoenix Project was written as almost a software sequel to The Goal, all right? Whereas The Goal is a business novel in that it teaches you about the theory of constraints, but it does so in the form of a page-turning novel about a fictitious business. The Phoenix Project is the same thing, except for a software business. Now, take the principles in The Goal, inventory, throughput, and cost, map them to a software business. All right, inventory becomes code, throughput becomes money, cost is still cost. All right, but that's the essence of DevOps. If you look at everything that DevOps tries to do in terms of putting processes in place, in terms of establishing CI/CD, in terms of establishing support and governance, in terms of making sure that developers are able to deploy as infrastructure as code and understand what their code is going to do in production, right? All of these things are there to make it easier for businesses to convert code into money faster. The longer that code sits around lingering in the organization, the harder it is for businesses to develop around that code, because you have, code is absolutely an expense. That's why we have to convert code to inventory as fast as possible, or excuse me, to throughput as fast as possible. We have to convert that code inventory into money. The way that you do that is through frequent releases of your code. All right. If you're doing 2-week releases, then you have a whole bunch of code inventory piling up. That makes it really hard to develop around that monolith, because if you tweak one thing here, you might break something else in the release, right? So you end up with code that just sits in the business, causing expense. It absolutely is an expense, right? Until that code gets released successfully and then is hopefully making more money for the business. All right. So what does all this have to do with Kubernetes? Well, Kubernetes is like a DevOps machine, all right? When combined with a CI/CD pipeline, you can decompose your large monolithic applications into mini services or microservices, which can be developed independently according to 12-factor DevOps principles. You can then release that code into a Kubernetes substrate environment, and it's very easy to take advantage of something like a service mesh at that point, to do like canary releases or blue-green releases, to ensure that when you push that new code to production, you're not going to impact a lot of users. If you break something, obviously, hopefully you did all your automated testing and diligence and things like that beforehand. But now when we have a code system that's able to take developers' code and commits, and immediately within seconds, or seconds if you're Amazon, minutes if you're, other organizations that are just getting on board with this, that code doesn't sit for 2 weeks anymore in between releases. That code goes out to production immediately now. All right, so tie all that back to reducing friction in an organization and eliminating bottlenecks in an organization. That is what business drivers in an organization constantly strive to do. That's why Kubernetes is so valuable. All right, Kubernetes represents the next deployment pattern in terms of trying as much as possible to eliminate friction from the deployment process, to convert code into money for the business faster. Right. So I know there's a long explanation, but it's really important, I think, because you don't, so many businesses make the mistake of like lifting and shifting their workloads to Kubernetes, or treating Kubernetes like it's VMware, and using things like node select and stuff to force Kubernetes to run workloads on persistent nodes so that the picture looks just like they had on their VMs. And if you're doing that, you're doing it wrong. And the reason is, going back to the original statement, Kubernetes is way more complex than a virtualization layer. There's way more going on. right? From everywhere from the operating system level all the way up to the orchestration level, all the way out to the software-defined networking, all the way to east-west communication and north-south ingress, right? So when you deploy out to Kubernetes, you absolutely increase your complexity. So the only reason, the only way to make that work for you is if you developed your application according to 12-factor principles that will allow your code to constantly release into that environment. Otherwise, all you've really done is increase complexity without actually reducing cost or cost of ownership. So, OpenShift builds on Kubernetes and adds more DevOps tooling from Red Hat. It sort of controversially switches the network fabric to a solution called Open vSwitch. But for all intents and purposes, the core is still Kubernetes, right? And I guess if you dial this all back to multi-cloud, as long as your app is suitable for Kubernetes, now that most major cloud providers have installed a Kubernetes engine somewhere in their cloud, then you can consider Kubernetes to be your multi-cloud strategy, which is yet another cost optimization feature that CTOs, CIOs, and all those folks are thinking about.
Yeah, this is really interesting. And so to kind of get back to the whole concept of the webinar here with the OpenStack Builder, again, you have to refactor your technology if you want to leverage Kubernetes. You have to look at what you built before in whatever environment that was, and you have to incrementally build it out as services that then run through the Kubernetes framework or OpenShift, for example, if you go up the stack a little bit here. So the question becomes then, when I was talking about cloud native as the sort of vision of the future, what you suggested, which I think is very clever, is look, as long as what you're deploying adheres to these basic design principles, you should be fine. You can put it out there and see what it does and let it kind of rock and roll. But maybe you could go ahead and share your screen now and walk through this OpenStack Builder, which I think is a really clever construct, because what these folks did, everybody, is they built out this OpenStack Builder, and it allows you to see the different component parts of a stack, and it gives you some information about what's involved in this component versus that component. And here we go. Yeah, the cloud native interactive landscape.
I wanted to show this first because I feel like this kind of sets the stage for why we built the Stack Builder. And I want to talk a little bit about, what we were hoping to bring to market with this. And it is a living tool, by the way. We've got stuff to make it pretty dynamic to continue to add technologies to it. But I like to start here because this is a very powerful visual right here. What you're looking at is, according to the Cloud Native Compute Foundation, and not truly according to them, as this is actually what you're looking at here is actually a crowdsourced open source application, whereby there are a few standards, but pretty much anybody who ships a product, whether it's open source or commercial, that fits into one of these categories that are essential for building a cloud native strategy. So containers, we talked about service mesh, but also service proxies, API gateways. Here's Kubernetes in our orchestration layer, right? This effectively, it's a crowdsourced application. So anybody who has a product that fits into one of these categories can basically just issue a pull request to this website and add your logo to this list. Now, you probably may have heard, if you've seen some things about cloud, Kubernetes, any of that. Kubernetes is NASCAR, I think, is a metaphor that I've heard, which is pretty good. It's about going fast, and there's lots of logos. That's basically what you're looking at here, are the lots of logos. The ones that are clear are open source. The ones that are grayed out are closed source. Okay. In order to build a real all-encompassing cloud-native digital transformation strategy backed by healthy DevOps, deployed out to cloud-native substrates that are frictionless and seamless, and to really achieve this type of deployment, you need a strategy for pretty much all of these pieces of the landscape. Okay. So in response to that, we looked at a lot of the work that the enterprise architects who work for OpenLogic are kind of doing in person right now, right? Oftentimes, businesses will engage with us in either a support capacity through our long-term advisory support that we offer, as well as through maybe professional services or even training. They'll come to us to kind of curate best-in-class solutions for what they're trying to achieve with their business. And going back to this landscape diagram, right? I think it's fair to say that, you know, when you hear about terms like tyranny of choice or open source complexity or just the overall complexity of cloud choreography and orchestration, I mean, I think it's very fair to say that. I mean, look at all these individual fragmented technologies, right? So oftentimes businesses will engage with us, will engage with enterprise architects from the team to get, you know, a veteran opinion of, you know, which of these technologies are really the best ones to choose for their needs. And we look at a lot of stuff when we help businesses make these decisions, right? First of all, I think it always bears mentioning, especially that for open source, that often the purpose and therefore kind of the function of that open source project is not as vertically integrated or completely off the shelf as you might be used to with a commercial solution, right? In other words, what I mean by that, take Kafka, right? Eric brought up Kafka earlier and brought up that it was donated by LinkedIn, by people from a company who are now part of a company called Confluent. And LinkedIn had a problem, right? They have all of these events happening within their platform, within their social media platform. People, you know, posting articles and people, you know, tracking other behavior, and they had to come up with algorithms to help, you know, stream all of this data and be able to deal with it in multi-regions and be able to analyze large sets of it so that they could perform all the analysis that they wanted to perform on that data, you know, so that they could, you know, use algorithms to connect people and to advertise to them and all the things that they wanted to do. And there wasn't really a streaming solution that met all of their needs at the time, right? There were some big data solutions that are out there, but Hadoop, you know, has never really been like as full streaming capable as it could be, and was really more batch oriented. Streaming analytics was still, you know, kind of a locked up technology that was very expensive and held by a lot of commercial companies. So they just decided to write their own. And they built this very scalable, very fast event system. Really, I don't like calling it a messaging system. It really is more of an event streaming platform, as well as a time series database that allowed it to kind of meet their needs in terms of that streaming. And then they said, well, you know what? There's other companies out there that are having to solve these same challenges. So we're going to just open source this project. So it was purpose driven, right? It's not like Kafka was released as this full analytics system, right? On its own, Kafka doesn't do anything. Right? You turn it on and it literally just sits there. There's nothing to do, right? It needs something to provide data to it. It needs places to ship data to, right? It needs consumers to ask for data. It needs producers to put data into it. So it's part of an overall data solution. That tends to be the experience when you're building a full solution with open source, because these solutions were not really envisioned from the beginning as full vertically integrated commercial off-the-shelf solutions that provide all the functionality that you need. Generally, you're going to be combining multiple pieces of technology to form a full stack that would be your solution. So for instance, take Kafka. When you combine Kafka with the open source technologies, Spark for analytics and Cassandra for persistence in a database technology, you end up with a nearly horizontally infinite scaled big data system that can distribute multi-regionally. And what you're actually combining then is the best-in-class persistence technology from Facebook. All right, Cassandra was used to track all of Facebook's, to store all of Facebook's activity behind the scenes. So all of its social networking activity, when you would like things and when you would add friends and all that kind of stuff. Cassandra is an incredibly well-distributed, fast, right optimized database. And then you can pair it, literally just pair it with the best-in-class messaging technology from LinkedIn. So two of these dominating social media platform people both donated essential parts of their infrastructure that they built. And combined, you now get these disruptive data lake solutions that can easily outperform, some of the massive commercial data crunching solutions from just a couple of years ago, right? So that's the real power.
Yeah, and that I just want to comment on that real quick. That's a very good description, because what you're talking about, again, it gets back to this concept of Gestalt, right? This German concept that the sum is greater than the whole of its parts. So a tool by itself can be very powerful, but when you couple it with 2 or 3 other technologies, all of a sudden you expand the value, sometimes logarithmically, basically. Meaning it's an incredibly powerful environment. So for net new use cases, if you've got a new business model and you've got a big idea, it makes sense to start, if you have, of course, the wherewithal to do so, to start with these technologies. But the legacy that we talked about at the top of the hour, 80+% of what is existing that runs businesses today, it's very difficult to migrate out of those systems. So just very quickly before you go to the stack builder, maybe as you go to the stack builder, to me, that's the big drive for organizations, is to look at their existing systems and to figure out where they can port into a cloud environment, where they can leverage these new technologies. And then you start with some project and you try to build around that. So what Kubernetes actually does, let's say you get an instance, you have a vision for the future where things are going to go, you're going to start tackling one specific challenge in your business, whatever that may be. It could be procurement to pay, it could be order to cash, it could be any number of things that you're trying to solve for, but you start somewhere and then you want to start building on top of that. Is that about right?
I think that's part of the infrastructure process for sure, right? Yeah, I mean, on the side of, in terms of like deploying a substrate out there. When I say substrate, I really just mean a place for your applications to live, right? You'd start by deploying the infrastructure out there. In the end, deploying Kubernetes is not difficult now, right? We've built all types of automation to do it. I think there was a question right before the show about how can I, have the whole Kubernetes experience and play with the whole thing on my laptop. Well, you can. There's a solution called Minikube, totally free and open source, Minikube. You go download it, run it, and install it. It'll set up a full, certainly not production class, but it'll set up a full Kubernetes implementation, including control plane, worker nodes. It'll install all the Kubernetes API tooling right onto your laptop so that you can use it as if you were using a traditional production cluster. And this is by design, all right? Kubernetes was meant to be able to scale from the absolute smallest workload possible up to, billions and billions of workloads, but provide what we would call dev production parity, again, in the 12 factors. In other words, the environment that you're deploying into on your laptop will match in terms of the API commands that you throw at it, and in terms of the declaration that you put in place for your deployment with whatever you would actually end up throwing at production, which solves yet another problem in DevOps, but is very clearly called out by the 12 factors, which is dev prod parity. So what it doesn't do is refactor apps to run optimally inside that substrate, all right? Where you then have the challenges is really starting to migrate workloads efficiently over to Kubernetes. And I can't stress enough that simply lifting and shifting these applications into Kubernetes is not only not going to really buy you anything, it's actually going to make things worse because you have significantly increased the amount of complexity underlying the substrate of your app. You've made it harder to trace into the app, right? Now, if you've refactored that app for 12 factors, however, you're going to have a much better time with it.
Well, and part of it too is that, some of these legacy environments, if you think about the code that was written, I remember a great quote by Michael Stonebreaker, the guy who invented the Postgres database, arguably invented the modern database, Dr. Michael Stonebreaker. He said, and this is probably 6-7 years ago now on DM radio, he said, 80% of the code that we have written over all these years should just be thrown away. And his point was that it was written with different constraints in mind, like spinning disk as the de facto persistent storage. Well, that we have a much different world now with all these new A processors, but flash memory, in-memory storage. They're all the different component parts of the environment have changed. They've evolved significantly. So a lot of the code that's running some of these legacy systems is tremendously inefficient in a cloud environment, right?
Absolutely, and even down to the very operating system. Like for instance, we're having a lot of folks who are a little concerned right now about the future of CentOS, the CentOS operating system, because of the recent announcement about their focus on Stream for CentOS 8. And I think that the reason that's caused some some consternation, I guess, is that there's not really a clear path for where you're supposed to move next, right? So to that end, I think we see the opposite of this effect, where it's like, okay, now we've actually increased friction in the organization by making a choice that wasn't necessarily completely thought out. So.
Yeah, good point. Well, let's see the stack builder in action here.
Yeah, sure. So, you mentioned something earlier that I think is really key, and that is that a lot of these technologies are better together, right? So again, going back to that notion of not really being like a vertically integrated commercial off the shelf solution with any of these things. These products that you see here on their own don't do very much. Even Kubernetes, fire it up, but if you don't have an app to put in it, you're not going to be able to do anything with it. So, but if you look at some of these combinations that we can make here, like starting with Kubernetes, for instance, and then combining that with mesh technology like Linkerd, now all of a sudden we can have an orchestrated and containerized environment that we can use system choreography on and everything. And we can have a service mesh that unlocks things like canary release patterns and blue-green releases and things like that, right? So on its own, Kubernetes is great, but add one of these service meshes to it and it gets even better. So that is kind of the essence of the stack builder. That's what we wanted to be able to do with stack builder. We wanted to be able to, we knew that customers, users were already coming to us and say, hey, we really need someone who's seen the way that these technologies operate, how they truly operate in production, have seen kind of the pitfalls, how they operate in the corner cases, to really curate for us the right solution for what we're trying to build. So often there's a very by hand process, sometimes in the form, if we were doing like just full transparency, if we were doing like a pre-sales action or something like that, and doing one of these curation exercises, we would go in and we would look at what they needed to do. And then we choose from, not the whole landscape of open source, right? But since we tend to target the enterprise, we look at open source projects that conform to a number of specific, that have a certain number of characteristics in terms of like the size and strength of the community, how fast that community responds to security vulnerabilities and things like that, the community governance model, the number of contributors to the code and the number of committers to the code. We try to look for long-term viability in the product, things like that, as if we were assessing a real product. Then, from that pool of curated and almost certified projects, we'll start making technology recommendations, and more importantly, recommendations for combinations of technology to help the business move forward. So we decided we wanted to be able to replicate some of that functionality out on our website. Right? We wanted folks who were kind of struggling with the complexity in this landscape and not really knowing exactly what to choose, to be able to have something where they could come in and just kind of play with a lot of the technologies that we would stand behind in terms of really being enterprise ready and ready to run at production scale, and then download an asset that they can use internally to do really whatever you need to do, whether you're trying to demonstrate a software architecture and you want a picture of it that's useful, whether you're trying to evangelize the use of some technology to your boss, right? There's a lot of different ways that you can use this tool. The tool is effectively a layout of sort of an N tier style of application, as that still does represent, I think, most applications that are in the enterprise. But you do have the ability to add some container, cloud, as well as workflow technologies. Right now, we're just focused on infrastructure as code technologies, but we're also going to be bumping this out a little bit and adding a whole SDLC tool chain to this pretty shortly. We built this tool to make it pretty easy to add additional technologies to it. So let's start with the easiest approach, right? Let's say that you know what it is that you're trying to build in general. You just aren't exactly sure what the best combination of technologies are to kind of make that stack a reality, right? That's where these templates come in, right? So, let's say, for instance, that you wanted to build a big data stack. And again, you wanted to build it according to what you thought was sort of best in class or curated. So when we click this big data stack, we're going to pre-populate a number of technologies in here that we would stand behind in terms of building a big data solution on. So you can see here that we've effectively built a data lake. We have all the substrate in place to build a data lake running on top of Kubernetes, right? Choosing Cassandra, streaming from Kafka, and reduced through Spark, and adapted through Apache Camel, all in the data layer. Right? We've chosen Ansible to manage our workflow for infrastructure as code, although given that we're using Kubernetes here, obviously there's going to be Helm and operators and things that are working alongside with it, as well as the standard approved monitoring, that being Prometheus and Grafana. Prometheus is native to Kubernetes, very easy at scraping metrics, very good at scraping metrics. Then if you wanted to add, like, say, an ingress point to this, you could come in and add, say, a front-end technology like maybe Nginx to the mix, right? And you do that by just selecting the technology and actually just dragging it into the substrate. And you don't have to worry about putting it in the wrong place, right? The tool is going to kind of keep you on rails in terms of where you put it into the stack, right?
That's very helpful.
That was, again, we wanted to give, like, the first iteration of this tool. This is actually, you're actually looking at Stack Builder 2.0 right now. The first iteration of the tool was even more on rails. It was basically like you'd answer a series of questions, like what were you concerned about, frequency of data or integrity of data, right? And then it would kind of pre-populate based on those questions. But we found that this tool is just really more useful when, you give a template approach, but then allow some free form capabilities too. You can use it for more stuff. All right, but let's say that you finish building this stack out, and now you want to validate the technology stack. You want to get something, an asset that you can use to evangelize this stack internally. You can download a report. This is just, and when you download the report, you get this nice sort of PDF copy of the stack that you've generated. And then we do a lot of sort of editorial content alongside each of these technologies. Like, I mean, this one stack just generated a 7-page white paper style report for you, on each of these technologies, talking about, why we curated them for this tool, why it's an important consideration, right? So you get a lot of what would normally be in the form of, I think, an in-person discussion with one of our EAs in the form of this report, right? Great, so that's like a full stack, right? That's like we came in, we knew we wanted to do something, build data, big data. We wanted to build on something, that was enterprise class and that was curated by experts and that, something that we could trust. But let's say we're coming in and we're really just evaluating like one or two pieces of technology, or maybe we just kind of want to play with building a more free-form stack, right? Maybe we want to build, I know we have a template for Java serverless, which kind of looks like, this. We have Spring Boot delivering apps with a Kafka data layer. But let's say that we wanted to get a little bit more flexible with what we were building for our Java serverless. Well, we would start maybe with our application delivery. Now, we could use Spring Boot because we are going serverless. Maybe we want something not necessarily serverless, but stripped down at least. So we could go for Tomcat. There is, of course, Tomcat runtime inside of Spring Boot. But maybe we wanted something that was a little bit more, server oriented. We could go for Tomcat. But let's keep our Spring Boot technology choice here. For the data layer, we're building a serverless stack. And we could either be building a stack here that was, that had an interest in reading and writing to a data source or backing service immediately, or it might just want to stream data out somewhere else, right? It might just want to expose data through something ubiquitous that could then be picked up by some other service. So let's say that's what we want to do, right? RabbitMQ and Kafka are both good choices for that. Let's say that our workloads aren't huge, but we really need guaranteed one-to-one delivery of messages, right? Kafka is famous for delivering at least once in the way that its replication works, right? Which is just part of concern for messaging systems. I'm still working on it, but there's an equivalent cap theorem for messaging that's really close. I think you remove partition tolerance and you replace it with throughput or something like that. But I don't know. You can't really have them all. But let's say that integrity was really what you needed. So you went with RabbitMQ then for the data layer to push that out to other workloads. And let's say you wanted to run the whole thing on maybe you're a little scared of what's happening with CentOS. So you want to run the whole thing on SUSE. You want to monitor, obviously, so for your monitoring technology, this is a Java serverless stack, so we could really benefit from Hot IO here, which is a really nice dashboard that can peek into the JMX tree from a Java application. And maybe we also want to populate longer term monitoring into Prometheus, and we want to visualize with Grafana. Great. Let's download that report.
And what some attendee is asking, is the tool available online or is the Stack Builder proprietary? You can go online and grab this thing anytime you want, right?
Openlogic.com. It's available to you right now for free. You do have to punch in your email address, full disclosure, but that is it. And you can start playing with it immediately.
Well, and I love that you publish this report, so you've got a foundation to start the process in meaningful fashion of knowing the component parts you're going to need, being able to kind of map out, and obviously Perforce can go into some of these environments and offer your consultative expertise about what, how important this component is versus that. What are the trade-offs? That's really the issue, right? Is that there are trade-offs, and you have to know the ins and outs of the technologies to know that. So you talked about Kafka having to deliver at least once. I mean, they've hardened that over the years. I actually asked Jay Krebs myself about that a number of years ago on a call, and he said yes. Of course, that was the beginning, and they've worked on that. But the details matter, right? And the details are going to map to very specific use cases. You have to know what you're trying to build, but then this gives you a good running start to know where to go and what to use, right?
That's the hope. Yeah. I mean, again, we really want people to be creative with their use of this tool, right? I mean, we originally envisioned it just as a way for just frankly, to be able to scale some of that early curation work that we were doing for customers, and to be able to give them a sense of our expertise, but also really to be able to help them, to really be able to provide them something of value. I mean, the mission of OpenLogic has remained clear for the almost 20 years that we've been in business now. And that is just to enable enterprises to safely and securely use free software. That's it. I mean, that's been our mission, and it's still our mission, and everything we do is in support of that mission. And we believe it's a very noble mission that is non-zero sum, because when we see enterprises really succeed with free software, we see those enterprises help support those free software communities. We see them start contributing code, sometimes even hiring individuals from those communities, sponsoring events and that sort of thing, which then accelerates the pace of those communities. So we really see this as something that helps global innovation at scale, when we can make it very easy for enterprises to consume free software. And that was very much the purpose of this guide. We would do these workshops to make it easy and help enterprises eliminate friction in their reduction of free software, because we want in our bones for enterprises to be successful with their use of free software. So that was kind of the purpose of this, right? We had our certification process that was already in place, and we had that knowledge inside the organization. And we said, why not, build a tool that gets some of that knowledge out there, and that's kind of fun, and that kind of takes some of the stress out of curating some of these solutions, which we all know. I mean, the whole industry is under enormous pressure to perform right now. We know that IDC is now predicted that by 2022, 2/3 of all parts of the global GDP will be digital assets by 2022, by the end of this year. So, 2/3 of things we pay for will be in the form of a digital asset. That's a tremendous pressure on the software industry to keep pushing quality software and to keep innovating, right? And so that's what we want to be a part of. That's what we want to help you do. We want you to use these products. We want you to be successful using them.
And I think you made a really good point talking about paying attention to the projects themselves. How many committers do they have? When's the last commit? I actually came across a really cool blog last night, someone on Substack who was just tracking all the new open source projects and saying, this is the last commit. This is how many people are involved. That critical mass of developers or of committers, for example, is a really good, I'd call it a leading indicator about the stability for a particular technology, right?
It is not just the stability, but also I think the longevity, right? Whereas I think that the goal of open source software and this open source software movement has always just been to create high quality software. That's always been the fundamental goal of the open source initiative, is to make good software just in a different way, in a more of a crowdsourced and social model for development. So I think that that goal. That goal hasn't shifted at all. So I think communities are already dedicated to making their products really good. That's what they want to do. They wouldn't be volunteering their time, if they didn't want to make their products good. So I think that software quality, it's going to be related to how fast you see the community releasing patches, commits, vulnerability patches, and things like that. Quality really matters. But longevity, I think, comes from having that community inertia, having enough people who care about the product to be able to pick up the baton when other community members leave. Thanks to you, Martin, for attending. Community members leave. Do you have enough people in place to backfill them and carry on the work? And because if you don't, then you really could end up in a bad situation for enterprises. Enterprise legacy apps still carry a lifespan of 20 plus years in a lot of cases. And so if you really commit to a technology that doesn't have a ton of staying power, we've even seen businesses that have been put into a situation where they've had to pick up the community on their own, or else they really would have been in hot water. So David, I see, is asking if this runs on a Mac. Yeah, it's web enabled, HTML5 web enabled. In fact, what you just saw, that demo, is running proudly on my Mac.
That's great. And getting back to hybrid cloud and really the future of enterprise computing and where things are going right now. Again, if you take this cloud native approach, these 12 principles that you've talked about, and you embrace them from a DevOps perspective, and obviously we talk a lot about data ops on this show too. Don't forget about the data and managing the data and who's touched it and so on and so forth. But I think the key is to enable yourself to leverage what comes out of these new cloud environments. Amazon Web Services, Microsoft, and Google are the three major players, it seems to me. I guess IBM is making a push now with the Red Hat. One of the rumors that I've heard is that IBM's cloud will be fully open source. I'm not sure if you've heard that or not. If you can comment on that, I'd be curious to know. But the key is to be able to leverage these environments because they are changing. And I'll throw just one last sort of curveball at you to comment on here. Which is, I've been thinking a lot about this and thinking about where things are going, and so these different environments. I almost want to say that we're entering the fourth industrial age of enterprise computing, and what I mean by that is you had first the mainframe, then you had client server, then you had early cloud ASPs, and that changed to software as a service. But now if you look at Amazon in particular and how much functionality they provide and how dense and robust that environment is, all the services that they've designed primarily bespoke for specific clients. But if you think about that new environment, designing for working inside that environment is another major shift in how we actually design software. And so that's when I think of cloud native as a term, that's kind of where I'm going with this, is that these new environments, these evolving environments like AWS have so much power and they are going to be the new center of gravity. There are companies, Curve is one of them we're working with, that figured out how to build a console, like a management functionality console inside your AWS environment that lets you pull in all the different services so you can build your own analytical products, your own data products inside your organization, instead of using traditional technologies like a Tableau or a Sisense or Alteryx or all these guys. I mean, you have all these different options for your analytics, but these guys figured out how to just let you piece together your technologies inside the AWS environment. That strikes me as a major shift, and I'm kind of calling it the fourth enterprise computing era. But what do you think about that?
I think that's a really interesting perspective on it historically. I think I might call it the fourth great abstraction. I think that each of these things, we add a whole new layer of abstraction in front of the compute that we're actually dealing with. Take it back to bare metal, you're dealing right with the metal. Take it to virtualization, you're dealing with an emulated VM on the metal. Take it to containers, you're operating on not even an emulated layer now, but just a file system trick, a shrewded jail in which your application runs. You're getting further and further away from the metal, but you're getting more and more digital, which means you're getting more and more flexible, right? Which means I can bounce my code around and throw it in the edge and all these different clouds and that, using complete automation to do it. And the cloud is yet another great abstraction layer between the physical hardware that we want our apps to be running on and the interface through which we can drop our applications onto the cloud, right? I think it bears mentioning always that the one thing that has not changed in any of these abstraction events, I want to come up with a term now that you've said this, abstraction event, global abstraction event, something like that have happened in these that have happened in these abstraction events. The one thing that has not changed has been that all the business cares about is the app. Right? That has not changed. The center of gravity for the business is still the app. Now it's how can we get the app out faster? How can we get it in more regions with better availability, with better fault tolerance to more users? How can we release the app more frequently? How can we patch the app more frequently? How can we decompose the app into microservices so that all of our developers can work on it and release all the time, right? So, but it's still all in service, to the app. Right. And I say, no matter how far you abstract away, that's still what businesses care about.
That's fascinating. That's a really, really good point. And I like this. I'm gonna refer to that as layers of abstraction, and just in a way to get really abstract to close out our show. First of all, I brought up this web page, folks. So this is OpenLogic. If you go to the main OpenLogic page, right here at the top, you can see, right here at the top, you can see this line, try our new OpenStack Builder and get a free customized report. So you just click right there. It takes you into it. And this is a bit abstract, but you're a philosopher too. So I'm going to throw it out there. I think a lot about deconstruction and these different concepts. And you're talking about abstractions, right? I did my thesis in college on Jacques Derrida's Structure, Sign, and Play in the Discourse of the Human Sciences. And he starts off, he says, perhaps something has occurred in the history of the concept of structure that could be called an event if this loaded word did not entail a meaning, which is precisely the function of structural or structurality, thought to reduce or to suspect. But let me use the term event anyway, employing it with caution, as if in quotation marks. In this sense, this event will have the exterior form of a rupture or a redoubling. And what he's really talking about is, in this context, where we're going with all this stuff. So we do have this new layer of abstraction. There's this new way of doing things, and the technologies are so much more powerful for lots of different reasons. Number one, scalability. Most of these new solutions are node-based, right? So they're designed to scale out as needed and then scale back down. I mean, I remember doing some research. It was like in, I want to say, the late 1990s into the early 2000s. If you go back to the sort of origins of open source, well, way back then, folks were working very hard on trying to figure out how to scale up for when Black Friday would come around or Christmas time or whatever the case may be. You would, in the old days, you had to provision a data center to handle the maximum throughput, which is really expensive. And then scaling down is very hard. But all these new technologies are designed around the principle of scalability, right? So the exciting thing, folks, is that if you take the plunge and you move forward with using these technologies, you can build your next generation system one function at a time. And that is going to allow you to compete in this new world, because, man, if you don't, you're either going to pay a service provider to do it for you, or you're just going to fold. What do you think, Justin? Final closing thoughts.
I mean, you're spot on, right? At the end of the day, it has always been a business rule that the companies that are able to produce the most efficiently, and whatever it is that they're producing, it doesn't matter, but the ones that are able to produce the most efficiently, as long as there's an actual market for it, I think we would presuppose that, are the ones that are going to rise to the top. They're the ones that are going to succeed. And it goes back to the goal. It goes back to theory of constraints, right? You see all these organizations that take all these steps to reduce costs in their organization, but they don't increase throughput at the same time, right? So in other words, they may have cut some costs, but they're not actually making any more money. Or they make all these investments in technology, but then their bottom line doesn't change. And then you go back and realize that it's because, oh, well, what we did actually just added a whole bunch of friction over here instead, or just created a whole bunch of additional cost over here, right? So I think, now we've got this real ability to, strip down the business to the essentials that it needs to support the application. And I think we've always known that modular application development is the best way to write efficient code, but we haven't had the automation, the tooling, to your point earlier, the data center technologies to make that level of automation feasible. There is no way that you could have, abstracted a whole data center into something as small as Minikube running on a Mac with the hardware that we had even 10 years ago, right? I mean, I think the closest that you could probably call out would be like the IBM I or AS400 infrastructure servers. Those servers were like full infrastructure in a box, like full ecosystem in a box. But those things are massively powerful and expensive. So.
This has been fantastic. Well, folks, we'll have Justin on future shows, I am sure. We do archive all these webinars for later viewing, but hop online. Don't miss this chance, folks. Openlogic.com. Look for the open source stack builder. I think this is fascinating stuff. Thank you for all your perspective, Justin, as always. And with that, we're going to bid you folks farewell. We'll talk to you next time, folks. I'll talk to you soon, Justin. Take care.
Thanks,
folks.
Eric. Take care. Thanks, everybody.
All right. Bye-bye.